I'm going to suggest you pause this video to read over the problem at your own pace and then come back when you are ready to discuss it. Okay, so I think of this problem as being broken down into three parts. The part that produces this, which is basically just that bullet. The part that produces these, which is basically the loop that does for each day. And then the part that produces this summary data, which is really described here. We have to produce the all of these outputs exactly. So we can kind of give ourselves space in the problem, and we can hop around to say, oh, I can do the black part and the blue part because I know what those print statements look like. And I'll probably use those same colors. Why not just keep that up? So if we're doing things exactly, we have a print that says my bird watching diary. And then I have an input statement with a prompt. I'm going to say it's days equals int input, and then there is a given prompt. Enter number of days. I'm going to skip a whole bunch of space and jump right down to the blue part, right? Because I know that it needs to have a statement that is like print summary. And maybe I'm going to give myself a little bit more space for that. And I'm probably also going to draw a line so that I help myself. I'll just draw a little line down my page so that I know kind of the level of indentation that I want to work with. This will define a first level of indentation. I've got a print statement that says you saw something birds. I know that the total birds is something that I need to figure out. So I can say you saw and then put comma T birds. Total birds. And that's a good reminder that I need to figure out the total birds and put it into some variable called t-birds. I can do that with all the other ones as well. Average birds per day. Oh, well, that one I don't need to deal with, right? Because I already have the total number of days in days. So if I know total birds, then I can just do a calculation. That's not an extra thing to think about. average birds per day, that would be t-birds divided by days. Location with the most songbirds, print location with the most songbirds, sloc. It's another thing that I gotta figure out and keep track of. So I'm just gonna say sloc is something I gotta figure out. T-birds is something I gotta figure out. Location with the most birds, bloc. And then I've got to do some complicated thing here. If only one parrot was seen for the whole trip, print cool, you saw a parrot. If more than one parrot was seen, print wow, you saw X parrots. So this is where I did not do myself any favors by making it close to the bottom, because that sounds like it's a bunch of ifs. And I need to somehow keep track of total parrots. So I'm going to say I'll keep that in some variable called p. And I'll just say if p equals 1, then I would print cool, you saw a parrot. This, where I only want one of these three messages to occur. Oh, wait. Oh, it's just two messages. Oh no, it's three. Yeah, no parrots. That's sad. I can say like elif p equals 0, print no parrots. That's sad. Else print wow, you saw p parrots. I guess it was an exclamation mark. Okay, so now I still have to do all the stuff in the middle, but I don't know, I have some decisions I've already figured out. Is that I gotta print that stuff. So I gotta populate T-birds, I gotta populate sloc, I gotta populate bloc, I gotta populate P in order for those print statements to work properly. So we've already figured out that we got some sort of loop. It's a definite loop. This example, we entered a 2, it loops twice. So I'll say that a sensible thing would be to have some sort of definite loop. For I in range days. And it kind of sounds like all of this is inside that for loop. All the prompting for locations, etc. So we got to ask for, well, I've already not done myself any favors because I haven't left any room between here and here. So I'm just going to go back a little bit and say, let's not assume that that is the very next line. Because indeed, there might be something I need to do. Okay, I need to prompt for the location. This will get Golden Gate Park. So I'll just say, hey, the location input location on day, so it looks like I have something that is programmatically changing. So I need some fancy way to prompt. That requires me, because input only takes one argument, that means I need to make that fancy programmatically by concatenating something to the end of it. So something like location on day, and then I would change this into the str of I, which is the iterator. This iterator is going to start at 0, and it looks like this is supposed to start at 1. So I'm going to turn it I plus 1, turn that into a string, and then concatenate to the end a colon. That's my fancy input prompt. I will prompt for the number of waterfowl, and it looks like that is going to be an integer. So int input total waterfowl then songbirds, and then parrots. I'm going to do PB, parrot birds, to differentiate it from P, which is my total parrots. All right, this isn't my total parrots, it's just the parrots that I saw at that place on that day. Okay. That has not helped me figure out T-birds or S-loc or B-loc, but it has accomplished these prompts. Now I can start to do some of the calculations related to that data that I just got from the user. I'm going to do those in a different color. I'm going to do those in green or something to say I need to keep track of the total birds, what I'm calling T-birds. So that means before, I don't like I don't like that. I don't like green. I don't have a lot of colors. Let's do gray, I guess. I'm going to say tbirds equals 0. I'm going to use the accumulator pattern to sum something up. Somehow my brush got smaller. Oh, I switched to a pencil. That's why. So my tbirds is going to be the thing that I'll sum everything into. So I would like to grow my tbirds. By the total number of waterfowl and songbirds and parrots. That'll be enough for my total birds. That total will come out correctly now. I also need to keep track of the total number of parrots, right? The same sort of accumulator pattern. P equals 0, P equals P plus PB. That is enough. That's how to total up parrots. I also need to keep track of the most birds and the location. So that requires something like max birds. I'd want to start this number very small so it's replaced, because that's the sort of trick we've done before when we've had to keep track of the max. So I'm going to make it -1. And I also need to keep track of the most songbirds. So max SB. And again, I'm going to choose something really small so that when I encounter something larger, it will immediately become the max and will then in the future get replaced in case I find something even smaller. So here's where I would say if songbirds is greater than max songbirds, then replace max songbirds with the total number of songbirds. And also remember S-lock as this location. And similarly, here's where I've kind of run out of space altogether. So I'm just going to write it off to the side and say here's where I need that other logic that says, hey, if max birds is well, I'll write it the same way I wrote the other one then. I didn't actually have a name for the total birds in this location because I just added up WF, SB, PB. So I'll say B equals WF plus SB plus PB. Then I could have just said this, tbirds plus B. I could say if B is greater than max B, max birds, then max birds equals B, and B lock equals lock. And I believe I'm done. We could have initialized block and slock to something. Don't really have any sample runs given to us of what happens if we didn't see any songbirds at any of the locations. So I can choose to say any behavior is fine since it wasn't defined. If we were making a real program, we might want to rethink that. But I believe that I've satisfied all the requirements of this problem. It gets a little messy on an exam. Hopefully I don't have to scrunch everything into such a small space, but we can see the benefits of giving ourselves lots of room so that we could say, hey, I really meant to have had an extra little line in between these. So if we give ourselves plenty of room, we can go back and sneak those things in as they are natural, whenever they seem natural. The tricky things in this problem, tracking the max is pretty straightforward. Tracking the location associated with the max is very straightforward. It's something we've practiced. Figuring out how to get this customized input is maybe a little tricky, although we've practiced it, so it's pretty straightforward too. I don't think there's anything particularly tricky here. It's just keeping it all straight and remembering what was asked for and finding an organized way to organize your thoughts to use the accumulator pattern to add things up, using the max finding pattern and min finding pattern. I suppose the initializations of maxes are always tricky. You could use a negative infinity float sort of thing, but you just need to find something that is reasonably smaller than any value that the user would input. I don't know what it means for the user to have found -12 songbirds. So I assume that -1 is smaller than anything the user would enter, because it seems reasonable that they'll either say 0 or some positive number.